Alright, so do a summary of question 5, okay? So it's basically this one idea on steroids. I used it many, many times. Okay, so the first one we saw was if you took x minus y squared, right? Get y minus z. Yeah. Okay. Do you see what you can do with that?
Yeah.
What?
I've got square minus y squared. It's the difference of squares.
Yeah. And then what?
Because you can get like x minus y is some difference of squares, right?
Yeah.
And you can do that.
You can take the cyclic product. So then you get x plus y, x plus z, y plus z. Equals 1, yeah?
Yeah.
Not quite. You have to still consider the case where like x equals y, right?
Yeah.
But if you do x equals y, then they're all equal. And it's a quadratic, yeah? Okay, so yeah. So that gives us an expression. It has sums of x plus y plus z's in it. It has x, y, z's in it, and it has like sum 2 at a time in it. And it has like sum of squares in it. Yeah. So it doesn't quite give us enough, yeah?
Yeah.
But then we're like, so actually when you do the quadratic case, yeah, you get x squared equals x plus 2, okay?
Yeah.
And what you can do is just factorize it, right? But like one nice way to factorize it is you just subtract a 1 from both sides. And you get x minus 1 all square, x minus 1 x plus 1 equals x plus 1.
Yeah.
And so then x either equals 2 or minus 1.
Yeah.
Yeah, so that's kind of cool, but obviously you didn't need it to solve this.
Yeah.
But if you saw this, you can actually do it for the general case. You can subtract 1 from both sides.
Yeah.
So then you get z squared minus 1 equals x plus 1. Yeah.
Yeah.
So if you do the same thing, right,
Mm.
and not worry about it, and then see what happens if x equals minus 1 separately, yeah, you get x minus 1, y minus 1, z minus 1 equals 1, yeah? Does that make sense?
Yeah.
Yeah. Okay, so from this, like, this gives you a bit more, this gives you different information to this for some reason.
Yeah. That makes sense though.
Hmm?
That looks more like what you want.
But fundamentally, I guess you have the product of x, y, and z, and you have the sum 2 at a time.
Yeah.
And here you also have that. So you have a kind of like, you can express the product and the sum 2 at a time in terms of the sum. Yeah?
Yeah.
Okay, and then we kind of got a bit stuck. And then, kind of like a crazy revelation, we did the same thing again. Instead of minusing 1, minus 4. Minus 2. Y minus 2. Like plus 2. Plus 2. So plus 2 equals 1. Yeah?
Yeah.
Does that make sense?
Yes.
Okay, so unfortunately we weren't able to like use these 3 and just actually solve for k. It didn't work. I think some of them are redundant. Yeah, but maybe I'll give you Liam some time stare at this equation and see if you can think of something to do that's interesting.
Oh, right. But just then go and put x squared, y squared, and z squared.
Yeah,
Oh,
which is kind of random. Alright,
x, y, z equals 1.
yeah,
Oh, and then probably use that with the other ones, right?
hmm. Yeah. Hmm. Is a contradiction? Because we didn't finish it. We finished it like, okay, from here, right?
Yeah.
We finished it by like, basically we got x, y, z in terms of the sum.
Yeah.
And then we put that into here and solve for the sum. But I feel like we can get a contradiction, can't we? I feel like it's a contradiction. Well, because numbers can't just multiply to 1 if they're like all bigger than 1, you know, like.
Yeah. But I don't think x, y, and z, do they have to be integers?
No, but like,
Yeah, that's fine.
but like if they were bigger than 1, right?
Yeah.
They can't all multiply to 1.
Yeah.
That's like a real number thing.
Yeah.
So like the absolute value of x, y, z is 1, right?
Yeah.
Yeah, so maybe we can find the contradiction, the way to express the contradiction. Mm-hmm. Yeah.
What's k?
K was the sum of the x, y, z.
Oh.
Yeah, so we got it. We got like we solved for the sum from here, yeah. But I wanna since we got a different. -10. Oh,
Oh, wait. Shouldn't we just have an immediate contradiction?
yeah. As if that could be like a really quick write up because there's literally like 3 lines, right? Or 6
Yeah.
lines, and then there's a contradiction, and then we just need to consider the exceptions. So tell me the contradiction. That'll be our exercise break preview. immediate contradiction.
I mean, we seem to have. But it feels like we should have already had that contradiction.
What do you mean?
Because the contradiction is that when we have x times y times z, then we have x plus 2, y plus.
Yeah, I'm gonna try this. So we have
contradiction.
x, y, z squared equals 1, yeah?
Yeah.
X plus 2, y plus 2, z plus 2 equals 1, yeah?
Yeah.
And x minus 1, y minus 1 equals 1, yeah?
Yeah.
What is the contradiction?
Stand bit.
Expanded and minus. I mean, you could.
That's what I did at my
But couldn't you use some kind of reasoning? Wait, what do you mean expanded?
Oh. Like spends.
Expanded and subtract.
But then you also have to expand and subtract the other two options. That's too much effort.
Okay. Yeah, I mean, three things, right? The product of three
Oh, wait,
things.
we have another contradiction. Right.
Too many contradictions.
Yeah. Oh, no.
Alright, give me to 3 o'clock. I don't want to spoil it.
Oh, that's weird, right?
Wait, you can do it too. You can do it without expanding anything. Hell yes. Some basic reasoning.
My brain power's like negative right now.
Negative.
Well, yeah.
Are you doing the Nutella thing?
I personally believe drugs are a great way to deal with that.
See, that's the conclusion someone with negative brain power came up with.
Well, yeah, I'm negative brain power right now.
Okay,
Stop.
so
You're giving me negative brain power by saying this video.
alright, look at this.
Yeah.
So if three numbers are all positive, right?
Yeah.
They can get to minus one. If they're all negative, they can't, right?
Yeah.
So you need either all positive or two negative and one positive, yeah?
Yeah.
So if it's all positive, yeah, that means x, y, z is all greater than 1, yeah?
Yes.
But if they're all greater than 1, then this is all greater than 3.
Yeah.
27, yeah?
Hey, we got that.
So you need two of them to be negative, yeah?
Yeah.
Okay, if two of them are negative, yeah?
Yeah.
Alright. Not only are they... So let's see, how does this work? If two of them are negative,
Is there a contradiction comes to negative?
huh?
Where does the problem arise? Because then you go, well, because then you go x, y, z multiplies out to -1, right? And then there's some sort of like that seems possible. Not an obvious, like not really, really obvious direct contradiction of that.
So like a similar principle applies here. Like if these are all positive, right?
Yeah.
If these are all positive, I had it before. So if these are all positive, so if x is greater than -2, y is greater than -2, z is greater than -2, right? Then, yeah, so if these are all positive, I think what you can do is you can look at x minus 1 on x plus 2, yeah? That equals x plus 2 minus 3 on x plus 2, right? And this is 1 minus 3 on x plus 2, yeah? You see? Do you agree?
Yeah.
Yeah, so if that's positive, right? Then they're all 1 minus something.
Yeah. Oh yeah.
You see? And 1 minus something times 1 minus something times 1 minus something shouldn't equal 1.
Yeah.
Should be less than 1. Yeah?
Yeah.
Okay, so they can't all be positive, yeah? So there has to be two negatives in both.
Yeah.
Okay, but two negatives, what does that negatives mean?
Increases.
It means that it's less than -2, right? Yeah?
Yeah.
So you got two numbers which are less than -2 times one number which is greater than 1.
Yeah.
It's supposed to have absolute value 1. You see that? That's not possible, right? Because if it's less than -2, then when they're times together, it's more than 4, right? Yes?
Yeah.
And so the answer should be timesing to more than 4.
Oh yeah.
Not equal to 1.
Then it's not possible that only solutions are the grabbing ones.
Well,
that's what this seems to conclude.
It means that one of the divisions mustn't hold, yeah?
Yeah.
So either y equals 2, like one of them equals 2,
yeah.
or one of them equals 1, or one of them equals -1.
Yeah.
Yeah?
Yeah.
And I think those are pretty easy to deal with.
Yeah.
If you expanded it, would have been another one here?
I think a line needs
What do you think? Do you think expanding would have been easier?
Depends what you mean by easier. Like, I feel like that's the, there's a, like, sure, it's probably more, like,
It's more routine.
Yeah, requires less brain power.
Doesn't mean it, but it's worse. Like, it's objectively worse.
Yeah, but someone whose mind is caught in negative or whatever.
Well, then the person whose mind is negative can do it.
Yeah, but that's you, Liam. Didn't you say your mind was like negative brain or something?
Oh, then you're gonna make my head hurt even more than it does.
It must be so tough scooping Nutella while being insulted.
I don't think you understand. Like, I cannot think right now. Feels like someone's stabbing a knife into my head every second.
Okay, you should